All right, this week we're going to start with segment or polygons. Now, we're going to be working questions 33 through 39. Now, let's talk about what's a polygon. First of all, a polygon has sides. Sides must be straight, and all the sides must be connected, all right? So, for example, I have a side there, I have another side, I have another side, and I have another side. They're all connected, so that's a polygon. Now, something that is not a polygon, it's that, because the sides are not straight, right? The sides have to be straight, so that's not a polygon. Something else that is not a polygon is that sides are straight, but they're not connected. So that's not a polygon. So the sides must be straight and they must be connected in order for us to be able to call it a polygon. Now we're going to be talking about the names of the polygons. The minimum amount of sides a polygon can have is 3 sides. So here, question number 33, let's talk about the names. The polygon with 3 sides, we can imagine a polygon with 3 sides. We're going to call that triangle. That's something you guys have known. Triangle. Now, polygon with 4 sides, there's many of them. You guys have heard about a rectangle, squares, rhombus, things like that. So in order for us to call it one name only for all the polygons, we're going to use the phrase, the word quadrilateral. Quadri means 4 and lateral means sides. So 4 sides. Now for number 5, imagine a polygon with 5 sides. There is actually a building in Washington, D.C. that has the same shape. And that building is called the Pentagon. Penta means 5 and gon means sides. So pentagon, 5 sides. For 6 sides, we're going to call this hexagon. For 7 sides, we're going to call this heptagon. Now, 8 sides, something you guys have seen, UFC. UFC has a ring that has 8 sides, and they call this octagon. 9 sides is called nonagon. All right, nona sounds like 9. Now, 10 sides, we're going to call this decagon. Notice it looks like a decade, right? Decade is 10 years, decagon. 11 sides, we're going to call this undecagon. And 12 sides, we're going to call this dodecagon. Now, for anything, polygon can have more than 12 sides, right? Minimum is 3, but it can have as many as I want. How does one that has more than 12 sides? Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right? A polygon can have more than 12 sides. Anything more than 12, we're just going to call this n-gon. N is the number of sides it has. So a 17 gon, I'm just going to call that 17 dash gon. Right? 50 gon, 50 dash gon. So those are the names. Those are the names we're going to be using. So for example, number 34 and 35. Here it says, write the name of each polygon. What I'm going to do is let me count the sides. Let me see how many sides there are. I'm going to do little lines when I'm counting my sides. So there's 1, 2, 3, 4, 5, 6, 7, and 8. Let me write n is equal to 8. What I mean with that is 8 sides. All right. 8 sides. Going back to my list, I'm going to call this octagon. Take a look at number 35. Again, let me count the sides. 1, 2, 3, 4, 5. This thing has 5 sides. So I'm going to call this pentagon. For the number of sides, for the name of the polygon, I just count the sides. And I go back on the list that I gave you guys on number 33. Now, number 36, we're going to talk about a convex and a concave. Now, concave, if you notice, it ends with the word cave or the phrase cave. Concave. Now, what a concave is a figure, is a polygon that has a dent, right? It has a cave. When we think about the word cave, it's like a hole in the mountain. So we're looking for a polygon that has a concave. It's a polygon that has a dent. Convex means it doesn't. So matter of fact, probably you guys have heard of the dentists talk about cavities. Cavities are basically holes in the teeth. Hopefully you guys haven't heard of insurances when they go check on the cars. They're like, oh, let's go check out the concavities of a car. Again, they're looking at the dents. So let's take a look at question number 36. Trying to see if I have for a concave. Concave means I have a dent. I have a hole in it. And I don't see one. One way that if we cannot tell, one way we can do this is by looking at the diagonals. Now, a diagonal is when I connect two corners that don't make a side. So for example, this is a diagonal. This is another diagonal, right? I don't see any more diagonals. Diagonals, notice I connected corners, but it's not a side. It's just the inside of the figure. Sometimes they happen to go outside. If one of my diagonals happens to go outside, it's a concave. None of them happen to go outside. I don't see a dent in this. This is a convex. One time a student told me convex sounds like convict, right? A convict are those people that are inside the jail. Here, convex, all the diagonals are inside the polygon. If that helps you. Now looking at number 37. Here I already see a hole in it. I already see a dent. This one right here. So I'm gonna call this concave. Another way we can use to find a dent is find a diagonal, but part of your diagonal, or probably all of it, happens to go outside. Look, I can come up with a diagonal that goes outside of the picture. Right, there's my diagonal that goes outside of the polygon. So as soon as you get one diagonal that goes outside, that's a concave. Or you could have just seen it, oh, it has a dent. Either way, you can find out for a concave. If it doesn't have a dent, it's convex. Now, question number 38 and 39, we're going to be able to learn how to classify our triangles. We're going to classify by angles and sides. There's two types of classifications. When it comes to angles, we go by the biggest angle. Let's remember the names of our angles. Right? If it's less than 90, anything that is less than 90, I'm going to call it acute. If it's 90, I'm going to call this right. If it's more than 90, right, less than 180, but more than 90, we call this obtuse. I know we talk about it when we talk about the name of the angles, we talk that an angle was 180 and we call that straight. Now, to be honest, you will never find a straight angle in a triangle, okay? It's either going to be acute, right, or obtuse. That's when it comes to angles. Now, when it comes to sides, the way we're going to label the sides, there's three names that we have for based on the sides. If all the sides are the same, so let me just write up here. all sides are the same. So the measurement of all the sides, the same thing, we're going to call that equilateral. Equal sides, that's basically what it means. Now, if only two sides, because there's three sides, right? Now, if two sides are the same, so two sides are the same, I'm going to call this isosceles. Now, if no sides are the same, or just say zero sides, that means all the sides are different. I'm going to call this scaling. So we're going to label it by angles and sides. So let's take a look. Angles, I say we're going to go with the biggest angle. So question number 38, the biggest angle is 104. It's more than 90. So based on the angles, I'm going to call this obtuse. Now, based on the sides, I noticed two sides are the same, 3 and 3. So I'm going to call this isosceles. The measurement of the angles are going to be inside of the triangle. The measurement of the sides are going to be outside of the triangle. So let's take a look at question number 39. When it comes to angles, I'm looking at the numbers inside of the triangle. The biggest number that I see is 78. Now, 78 is less than 90. So I'm going to call this acute. When it comes to sides, I noticed 13.2, 14.6, 9.6. They're all different. So I'm going to call this scaling. Now, 90 degrees, one thing, real quick. 90 degrees can be represented when you see it on your triangle as a number, 90, or it could be represented as a box. All right, sometimes I write a box. Let me zoom out, that way you guys can see the questions that we did today. Those are our notes.